Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to Organic Synthesis, the Art of Science, Session 5. Oxybuprocaine, also known as benoxinate, is an ester type local anesthetic which is used especially in ophthalmology and otolaryngology. Perform the retrosynthetic analysis of this compound. This compound has an ester functionality, amine functionality, ether functionality, and again a real amine functionality. Retro-analysis 1. Here is our target molecule. As we mentioned, we have an ester, we have an ether, we have amine. Well, the ester is very reactive species, so I will start by cutting in this, transfer it to carboxylic acid. Now the amine is still very active, but we can get it from less reactive nitro. So let's do function group interconversion and have this nitro. Now we can cut in here CO bond, and here we have OH. OH is also orthopara directing group, so it can direct the NO2 to ortho, and it's powerful, it's activating, while this is meta directing group but deactivating, so this will be the one in control. هي دي المتحكمة في الايه في التفاعل. So we can cut in here and we say, okay, I will start with 3-hydroxybenzoic acid. But how we can get this? There is two ways we'll know about, is the sulfonate fusion with potassium hydroxide. So we have to have benzoic acid sulfonation and then fusion with potassium hydroxide. But in the lab we can do it easy with replacing diazonium salt with water and copper 1 oxide. So we can get from diazonium, and diazonium we can get from the amine, and the amine we can get from nitro, and the nitro we can get from the benzoic acid. Carboxylic group is meta directing group, and benzoic we can get by the oxidation of toluene, and toluene we can get from benzene via Friedel-Crafts alkylation reaction. So this is a disconnection. Going back to benzene. Synthetic scheme, we start with benzene, Friedel-Crafts alkylation with metal chloride in presence of aluminum chloride, we get toluene. We oxidize toluene in alkaline potassium permanganate, then neutralize or acidify with HCl to get the benzoic acid. Nitration of benzoic acid, nitric sulfuric mixture, fuming of course, we get the nitro, 3-nitrobenzoic acid. We reduce the nitrobenzoic acid with 10 HCl to get amine. Transfer the anilino with sodium nitrite HCl to diazonium salt, replacing diazonium salt with water, sulfuric water, or water copper 1 oxide to OH. Using fuming nitric in nitrobenzene, we get also nitration to OH. So we get the nitro compound, nitro also to OH. Now we protect the COOH group by transferring it with ethanol sulfuric to an ester. Now all what we need now, transfer this OH to the eth. So we reacted with potassium carbonate and butyl bromide, followed by potassium hydroxide water to return back the ester to the carboxyl group, and at the end we add dilute HCl for free acid. Now we would like to make the ester back. The ester, we add thionyl chloride to transfer the carboxylic acid to acid chloride, followed by addition of diethylaminoethanol. So we have the ester, we have now the ether. All what we need is convert NO2 to NH2. We can do that with hydrogen and catalyst like palladium on carbon or runny nickel. This method is reported in Synthesis of Essential Drug 2006. That's general procedure for this type of compound. Retroanalysis 2. Once again, here is an ester. We do the same, and the amine in here. Ether. How we can get the ether in here? Well, we will cut in here as previously done in retroanalysis 1. We get this. Again, we look for the nitro, less reactive. Here we are. This is electron withdrawing group, and this is electron withdrawing. This one, nitro, here is ortho to that position, right? So we can think about cutting in here, having this fluorocarbon-fluorine bond. So this molecule will undergo nucleophilic aromatic substitution with a nucleophile. Okay? And we follow the same synthetic scheme after that. So we start with this compound, and that's, by the way, commercially available. React that with potassium hydroxide in heat of butanol, so forming the alkoxide which attacks on this carbon, nucleophilic aromatic substitution, giving this species. Again, we do the same step as I mentioned in the synthetic scheme. When we form the ester on this carbon via acid chloride, and then we reduce the NO2 in the last step. See you next session.